In civil engineering and construction, the word load is often used to describe any force, weight, or deformation that is applied to a structure. Because a load is a force, then it has the same unit as force, which is the Newton. Take for example these vases on this dining table. The vases exert their weight onto the tabletop, hence creates a load on the table. The table in turn exerts its weight onto the floor, thus creates a load on the floor. Let's look at some different types of loads. Loads on a structure can be divided into two main categories: dead loads and live loads. Let's look at these loads in more detail. A dead load is a force that is permanent and constant over a long period of time. It is usually the self-weight of the structure members that make up the structure, plus any immovable fixtures. Take for example this modern home. The dead load on this structure includes the house foundation, the house frame, the walls, the roof, and the swimming pool. There's a subclass of dead loads called superimposed dead loads, which are semi-permanent loads that are not part of the structure itself. In this house, the superimposed dead loads can include the carpet, the floorings, light fixtures, the bath and vanities, cupboards, kitchen, the air conditioner or heater. These loads are fixed to the house but can be removed, so are not permanent. A live load, on the other hand, is a load that is dynamic or temporary. Dynamic loads can include loads due to impact or vibrations, or forces due to wind and rain. And temporary loads are loads that can move or change depending on its functionality. Back to the example of a modern house. Live loads here would include the furniture, the water in the pool, appliances, decorations, and the people living in the house. Most dead loads and live loads on structures are vertical loads and comes from the weight of the objects themselves, and so load can be equated to weight. We know from previous videos that weight is a gravitational force and is equal to the mass multiplied by acceleration due to gravity. So load is also equal to mg. So, if you want to know how much load a large concrete wall applies to the floor, how would you work it out? You wouldn't be able to easily pick it up and put it on a scale. It's not practical. But what you can do more easily is to measure its dimensions and calculate its volume. Then, knowing the density of the concrete based on its material properties, we can thus calculate its mass and therefore its weight. So knowing the density of various different construction materials is really important in being able to calculate the total load of the structure. A point load is a load that is applied to the surface at a single point or over a small surface area. Take for example this vase sitting on top of a coffee table. The weight of the vase creates a load at the center of the table where the vase is in contact with the table. It's considered a point load because the weight is distributed over a very small area on the table. The table in turn exerts a force at 4 points on the floor where the table legs touch the floor. The total load on the floor is the sum of the weight of the table and the vase, and each leg evenly distributes 1/4 of the total load to the floor. So if the mass of the vase is 1.5 kilograms, then what is the point load exerted on the table by the vase? Since the vase has a mass of 1.5 kilograms, then its weight is its mass times gravity, which is 1.5 kilograms times 9.8 meters per second squared to give us 14.7 newtons. Now, if the table has a mass of 4 kilograms, then what is the total dead load experienced by the floor? The weight of the table is its mass times gravity, which gives us 4 kilograms times 9.8 meters per second squared, or 39.2 newtons. Now the total load on the floor is the total weight of the vase and the table, which is 53.9 newtons. That load is distributed evenly across 4 legs, so each leg delivers 13.5 newtons to the floor. Of course, the floor exerts exactly 13.5 newtons of force back up each leg as a reactionary or normal force. In summary, A load on a structure is a force acting on that structure. There are different types of loads. Dead loads are forces that include the self-weight of the members or parts of the structure that are permanently fixed. Superimposed dead loads are semi-permanent forces, and live loads are dynamic or temporary forces. A point load is a load that is applied at a single point or over a small surface area.